Hey y'all, Mark Thomas here. Welcome to another episode of AI Safari. Today we're going to discuss a bit about machine learning operations, also known as MLOps. And perhaps not, or maybe perhaps surprising to some, the machine learning code itself is actually not the culprit here when it comes to challenges of effectively putting a machine learning code or a machine learning model in production and its overall performance. But it's great that we have Jody McCullough, Enterprise Account Manager, and Bob Glithero, Director of Product Marketing here to help us better understand machine learning operations. But before we dig in, Jody and Bob, will you share a little bit about your background?
Yeah, happy to. Thanks, Mark. So yeah, I'm Jody McCullough. I'm basically the enterprise or named account manager at Converge, which is an Intel company. I've been here for about 18 months in the MLOps space. So that's been a bit of a departure from my, I guess the rest of my career. I've been more of an infrastructure guy. I've worked at Cisco and EMC in the past. So but yeah, it's been an exciting ride here for the last number of months, and definitely looking forward to some future projects. Bob?
Yeah, so I'm Bob Glithero, and I lead product marketing at Converge. And so I came from VMware, actually Pivotal before that, where I led through the Tanzu data services portfolio. So our relational offers, caching, data warehousing, and messaging. And so I kind of come to this space, not really as an expert in data science per se, although we certainly had those use cases, but I come with a strong flavor of data management, CI/CD, kind of modeling application development. And so it's kind of an interesting background to come to this space because everything seems to be ops these days. And when people hear MLOps, they kind of think of things like, DevOps and CI/CD. They can approach it the same way, but there's some important differences between the two. And so coming from that world, it's kind of interesting to see how those types of principles get applied in the machine learning space when it comes to deploying models to production.
Yeah, thanks, fellows. I hope, Bob, you guys can dig into that a little bit more because I think that's pretty interesting and relevant for today's discussion. So I'll just kick it off here. So in a paper, I don't know if you guys have read this or not, but there's a paper titled Hidden Technical Depth in Machine Learning Systems. It's by Google's Scully et al. And they really point out very clearly that machine learning code represents only about 5% of the overall machine learning system in production, meaning machine learning systems are really comprised of about 5% modeling work, and the other 95% is engineering work. It was kind of surprising to me, maybe not to you guys, but we're going to kind of peel that back a little bit and understand why it's so heavily weighted toward engineering. But really, like you said, MLOps is formed by meshing three disciplines, and that's machine learning, of course, DevOps, and data engineering. And it's all collectively with a goal of automating and streamlining the machine learning lifecycle. So with that said, to level set on a basic understanding, can you guys define MLOps, machine learning operations, and what specifically is driving the need for this powerful tool set?
Yeah, sure. I'll take that question first. Everybody kind of points to their own set of statistics about how long it takes to get AI projects out of the lab and into production. I use Gartner research a lot, and their report, their own studies, it takes about 9 months on average to get out of the lab, and barely more than a majority of projects, make it to production. So they really take too long to deliver value if they're really delivered at all. And so MLOps is kind of a repeatable process to reliably deploy and maintain ML models into production. As you said, it draws from machine learning, DevOps, and data engineering. But the goal overall is to begin automating model lifecycles, just like you automate other software projects, with an ultimate goal of getting to very high impact models, but that can be continuously updated. So instead of the CI/CD process in most software projects, you end up with a goal of getting to continuous training and continuous deployment so that you can have an automated cycle, or you can involve human experts in the loop as needed, depending on whether your data drifts or your model drifts as well. But the idea is this goal of kind of this cycle of automation.
And when you say CI/CD, can you explain that a little bit?
Sure. So continuous integration and continuous deployment. So if you look at, the major kind of application development platforms, most of them have tooling, like Jenkins or whatnot, that basically facilitate the automatic building, testing, and deployment of products. And so what we're trying to do is to kind of get to the equivalent in the machine learning world. Software projects and machine learning projects, they look comparable on the surface, but there's actually a lot going on under the hood that's different. Like in traditional software development, so your goal is to meet a functional specification, and increment as new specifications emerge, and that's assuming that you don't have any particular, bugs or things that need to be remediated. But if you have a function that or a library that's already set, it should give consistent outputs given consistent inputs. Whereas in model development, your goal is typically to optimize to a metric like accuracy and then constantly iterate to improve it, right? And so in software development, your quality depends on the code, whereas in model development, you've got a number of things going on. You've got the code for sure, but you've got input data and tuning parameters, and all of these are evolving at different rates. So there's a lot going on that you have to kind of keep track of as you go, and your model accuracy drifts as new input data arrives, right? And so those are some of the, I think, some of the key differences, right?
Got it. So failure is inherent in machine learning work. But did I hear you say that there are opportunities to extract some of that failure out and improve the speed to production?
I think, yeah, and I would, rather than saying extract the failure out, I would like to say design repeatability and reliability in and consistency. I think that's a
Okay,
better
good.
way
Yeah.
of looking at it.
Yeah, yeah. And I didn't mean, I don't think you're ever going to get to a point where you can extract the failure, but some subset of that failure seems to be controllable and or somewhat controllable, and maybe MLOps can help address that. Is that fair?
Absolutely, because essentially instead of a fragmented landscape where you've got, different notebooks and different code and different models, scattered in different places, it's kind of hard to get a holistic view of what's going on in your data science program. It makes it kind of difficult for your team to collaborate. Whereas if we can kind of use MLOps as a basis for creating a centralized hub for data science in the enterprise, then you have a lot of benefits that come from that. Collaboration improves, obviously, but you can get to more consistency kind of in how you handle software. So you don't necessarily have to worry if one data science team is working with one version of a package and one version of dependencies. So you can improve standardization, which should theoretically improve the variability in results.
Okay, that makes sense. So within organizations, there are various degrees of data science maturity. So does an organization need to be at a certain maturity level before they start considering adopting a machine learning operations protocol or platform?
I'll take that one, Bob. So there needs to be flexibility in the platform. I think, to Bob's point, we're operationalizing data science work. So, if you've got a relatively straightforward environment with limited data sets and, limited notebooks and libraries, there are definitely advantages to adopting MLOps. But they really, I would say, get exponential value with increased complexity. So, the more data sets that there are, the more different sort of IDE environments there are, sort of that lack of common tooling, I think, really lends itself well to MLOps.
Got it. That makes sense. Yeah.
I think customers exist at a kind of a spectrum on their AI journey. And so I've kind of found it useful to segment in kind of 3 stages. Others, have their own models. But usually there's some form of experimentation where, customers are beginning to apply machine learning. But the process is very manual. It's very script driven. It's very ad hoc. And there's a disconnect between the data science team and the operations and infrastructure teams. You have infrequent releases of models, and you typically also don't have very much going on in the way of monitoring. So at that stage, the the goal is to transition from data science as a craft to increasing automation and optimizing the data science workflows. So then you can arrive at a stage where you're increasing your automation. So you have more rapid iteration of your experiments. You have modularized code. You have strong metadata management. You have reusability in your data and your models. Maybe you're looking at heterogeneous compute because you may, in a single pipeline, different tasks can be better served by different types of compute hardware. And each one of these presents a different cost and performance optimization challenge. And then finally, you're probably also looking at model serving and how to do that at web scale. So you want to get to a point where you can automate testing and deployments, not just development across many environments. And MLOps as a discipline is kind of really useful for bridging the world of data science with machine learning engineering. So on the data science, you're primarily initially focused on development and learning, whether that's data exploration, feature and model search, and then running your experiments to validate your ideas. In ML engineering side of it, you're more concerned with putting the models to work. So things like automation and scaling and observability become more important. And then finally, you reach a stage where, now that you've got all this automation, you're ready to kind of do deployments at scale and more sophisticated types of deployments. So you're ready to deploy entire machine learning pipelines. You're ready to adopt continuous training and delivery. A lot of modern software applications are deployed using Kubernetes as sort of a universal target. So maybe that's something that the machine learning engineering team is considering. Also, you have multiple serving types. There are lots of platforms that can do kind of web service endpoints. But what about streaming endpoints, right? Integration with, because there are other tooling out there that you have to consider in the universe, like Kafka or messaging services like RabbitMQ. So how does your development stack fit in with the rest of the software stack and maybe your distributed application strategy? And then finally, you also want to consider maybe how do you handle things like auto scaling, because sometimes the workloads can be bursty. And so you want to get to a state where you have rapid, reliable updates of the entire pipelines in production, and you can adopt more sophisticated deployment strategies, like Champion, Challenger, and Canary, all with dynamic scaling. And so, as you increase automation, you can do more and more sophisticated things and get more and more out of your MLOps platform.
That's awesome. That's fantastic. So is it, I don't know if you would agree with this, but it seems to me, and when I was preparing for this session, that MLOps is kind of it still seems like a nascent practice or discipline. And it seems like it emerged somewhere around 2012. And it also seems like the landscape is pretty vast, and it's expected to really grow before it starts to thin out to just a few key players, platforms. In fact, I think there are probably more than 200 plus open source and commercially available MLOps tools and platforms today. And you talked about some, but as you're sifting through all these MLOps options, what are some key considerations when you're choosing an MLOps platform for your practice?
Yeah, maybe I'll just take sort of a high level on that. Kind of back to the flexibility part of it. It's going to depend on kind of the level of complexity, I think, of the users. So, are they in a hybrid cloud environment? Is the data all on premise? Do the data scientists work with TensorFlow extensively, or do they work with TensorFlow and PyTorch? Really the ability to keep track of versioning and essentially compare the efficacy of models. So part of our story at Converge is essentially heterogeneity. So if you look at a public cloud offering, for example, if a customer's environment resides exclusively in that public cloud, then it might make a lot of sense to leverage their MLOps offerings. But if it's a little more complicated than that, and you've got some on-prem and you've got some in this cloud and some in another cloud, then you need a little bit more of a flexible platform. But I don't know, Bob, anything to add to that?
Yeah, so there are different requirements depending on kind of what objectives that you want to emphasize. So for example, AI explainability is a very big topic right now for regulatory and other reasons. And so you touched on a version control system for change tracking, Jody, and that's very important. not just for your model code, but for your data sets and for your hyperparameters and all of your artifacts, because you want to be able to basically repeat a particular pipeline or set of experiments easily. And if you have if you lack those automation features, it's going to be, and everything is fragmented all over the place, it's going to be very, very hard to do that. But the other thing is, nice to haves are like an internal package manager for managing all your software dependencies, reusing libraries and components, because that also helps with consistency and repeatability, but it also helps with collaboration as well. You'd like to have a central access controlled repository for all your notebooks, your data, your models and features and so forth. And it's also important, I think, and this gets neglected a lot, is how do you fit in with the rest of the software development tool chain that's in the organization?
Mhm.
Do you have integration with source code control for custom model development, like GitHub, for example? How handy is it to be able to create a local branch of your repository in a platform, iterate it, and then push back to remote, right? We talked a little bit about flexible deployment and heterogeneous compute. So I think these are all very, very worthwhile things to consider. I think one that also gets overlooked a lot is monitoring and observability. You should really have strong monitoring and observability controls, not just for experiment tracking, but also resource tracking as well. Because if you can bring together, the model training statistics with the resource consumption statistics, then you've got a basis for making more intelligent scheduling decisions going forward as you kind of confront that kind of cost performance optimization curve.
I have to say, that's a pretty comprehensive checklist for MLOps platform. That's awesome.
Well, we have opinions on that.
That's great. Well, this has been awesome. I'm going to shift gears a little bit. We're gonna end on a fun question. So I don't know about you guys, but I'm already planning for my vacation this year. And I want to know, when you guys are not immersed elbows deep in all things MLOps, what is one way you like to disconnect and recharge?
You first, Bob.
Okay, very good. So, I spend a lot of my time, like we all do, in front of a computer screen, whether on Zoom calls or what. So when I'm on my own time, I like analog experiences. And so I like to work with wood. So I do a lot of woodworking, a lot of
Nice.
cabinetry, a lot of things like that, because it really puts me in a different world. I really find that very relaxing. I don't know about you, Jody. What things do you like to do?
We may have lost Jody. I can tell you, Bob, that myself, I love doing DIY projects, and almost all involve woodworking of some sort. So I can appreciate how that's how you can escape with those types of projects.
Yeah, for me, guys, but I was a competitive power lifter for 10 years. So I would, try to lift as much weight as humanly possible. But I think I have aged out of that discipline. So I'm trying to take it a little bit easier, but that was a way for me to decompress by compressing my spine.
That's awesome. What's the most you've ever power lifted?
I squatted 600 pounds in a judged meet, so that's probably my most impressive feat.
Oh my God, that's three of me. That's impressive. Wow.
Yeah,
Okay.
so it was fun while it lasted. It's one of those things you're probably not gonna be able to do in your twilight years. So I've come to find out.
That's fantastic. Okay. Well, Jody and Bob, I really appreciate you guys carving this time out. Great to chat with you. Fantastic insight. I want to thank everybody out there for tuning in and listening. And please check back for future sessions as we track down another expert or experts to help us explore the wildly fascinating AI ecosystem. Cheers.